big problems come in C when you overrun memory. That's the biggest problem. I know I'm a broken record here, right? C, you have to manage your own memory, and by doing so, you expose yourself to making mistakes. Okay? Now, there are some historical procedures in C and Unix that are super dangerous and shouldn't exist, and this is one of them. Okay? So when I say scanf%s, what it does is it's going to read from standard input characters until it sees a white space character. So it's going to read the next word. If I've only allocated 10 bytes to that, the operating system has no idea. Whoever is implementing scanf has no idea that that buffer is only 10 bytes long. So if I read 50 bytes in here, it's going to overrun memory. Okay? A buffer overflow attack is when an attacker knows that you have something like this in your code. And so what they do is they can set it up so that what you're reading, it won't have any white space, but it'll actually have machine instructions in the format of your machine. And now as you start overwriting memory and you overwrite the stack, then when you actually return from this call, it runs their code. That is the classic buffer overflow attack. That's what happened in the 1988 virus when Robert Morris shut down the internet and you all were not even like twinkles in your parents' eyes, right? But that happened, right, in 1988. Have you all heard of this one? Robert Morris was a first-year graduate student at Cornell. At the same time I was a first-year graduate student at Princeton. And he decided to write some code that would live on the internet. No one's ever really determined his purpose on this. But a big thing was he had a buffer overflow attack. And it was in, who names these things? It was in the finger daemon. Isn't that a horrible, horrible thing for, and the finger daemon actually called, it called getS. This was the culprit. And getS, much like scanf with %s, getS, you just give it a pointer and it's going to read it until it finds a new line. So this one's an easier one than scanf%s because you have much more legal stuff you can use until it finds that new line. This is what the finger daemon, you used to be able to say, God, finger, you would like say, finger jplank at mamba3.ecs.utk.edu, and then it would come back saying I was actually on the machine. And so this was an operating system owned program that called getS. So what they figured out is I could say finger, that address.ecs.utk.edu, and now all that stuff's sitting on my stack. So he used that that was part of what he used to attack machines. He had a 3-prong attack. So he shut down everything. Everything got shut down that weekend. And then even government machines that weren't on the internet, they got shut down. And then the FBI kind of went after him, and then he might have gone to jail. Might not have. He's a professor at MIT, right? He lived beyond that one pretty easily, to be honest with you. So that was that. If you ever go to I think it's the Crime and Punishment Museum in D.C., they actually have a little exhibit on him. So that's how you get famous, is figure out how to exploit. Okay, that's what a buffer overflow attack is. It's a good thing to know. Good thing to try to avoid. How do you avoid it? Well, A, use fgetS instead of getS, right? It's because fgetS, right? Because fgetS, you have this size here, so it won't. If you call it correctly, it won't overrun your buffer. Calling scanf for things like ints and doubles is totally fine because you're only getting 4 and 8 bytes. You know what you want. If you know your input is correct, and I put a big if you know your input is correct, but if you know your input is correct, you can use scanf. If you know your words are only going to be 10 bytes long, then you can use scanf with 10 bytes. But that's a big if. You got to know. Yes, sir.
What does the restrict mean on the?
I don't know, JC, you know? Okay. Yep, no idea. I honestly have no idea what this restrict thing means. We'll have to Google it, but I'm not going to Google it in class. But I'm guessing it's something else to keep your life safe, right? Everyone wants to keep you safe in C, even though it's impossible to do so. Okay, that was scanf. scanf, just call scanf on a string. Now with scanf, you're a little safer, right? So with f here, let's see. So here, char x, no, yeah, here we go. X equals 10, 15, Fred. Right. Now I could say scanf x dds. Let me go solve my buff. Char buff 10. Bless you. And I buff. Now this one, I'm going to say I could feel better about. Right? Why? Well, because I know how big this string is. Right? And so I know I'm not going to overrun memory. Go ahead, part of it. I know that Fred is bigger than 10. Right? I can test if I'm doing this with scanf. I can check to see if things are big enough before I go ahead and make that %s call. So it is a little safer. Here, let me. Here. 82. We'll make this guy. There we go. GCC junk.c. All right. Right. Reads it in just fine. Okay. scanf is very nice. I like scanf. I prefer scanf to using a string stream, just because it seems simpler to me. But it is whenever you see a %s, you need to pause. It's just like whenever you type rm-rf star, right? Whenever you do that, you need to pause before you hit return, just to make sure you're doing the right thing. Same thing here. Whenever you do a scanf with %s, you need to pause and ask yourself, is it possible for me to overrun my memory buffer? Okay, strdup. Strdup gives you more or less what you want. Strdup, you give it a string, which of course is a pointer, and then what it's going to do is it's going to call strlen to see how long that string is. It's going to add 1 to it. It's going to call malloc for that, and then it's going to call strcopy to copy the string over. Yes, sir?
Isn't that char star x string 11 bytes because of the mainline character?
That's a good question. It is, but I know Fred's 4, so I'm good. Right, because I'm only reading the Fred into the buff. It's a good question. It's a good eye, right? But I'm reading integer Fred, so I know it's good, and it's only the Fred that matters because the Fred's the only thing that's getting stuffed into it.
I thought because there was quotes around it that the whole thing was like.
No, I did %DED, man. I'm reading 2 ints first. It's a good question. Okay, strdup duplicates a string and malloc's memory for it. Malloc's the exact right size memory for it, and then str copies it into it. So strdup is often what you want. Okay, and we'll be going over more of that today. I do want to caution you, strdup calls malloc, and so you got to remember, if you've called strdup, you've called malloc, and if that means you're going to have a memory leak in your code, you need to pay attention to it. And if you need to free it, if you need to get rid of it, you call free. You don't call stir free, you call free on it, and then that'll free up what you got from strdup. But strdup is nice because it gives you what you want. Okay. I'm not even going to bother with an example. There are, in these lecture notes, just so you know, at the end of these lecture notes, I do give you even more procedures that you can use to manipulate strings in C. Give it a read over. Just give it a once over. I will say memcopy is one. I probably will go over memcopy at one point. Memcopy is very important. Memcopy, you give it a destination, a source, and a number of bytes. And then it's just going to copy those bytes from source to destination. So it's different from strcopy, right? Because strcopy looks for the end of the string, and it does that. Memcopy, you say exactly how many bytes you want to copy. Yes, cool.
Can we do an example of freeing after using strdup?
I will. I will in this class. So, yeah, no problem. Hopefully. If I don't get all chit-chatty. We're distracted by people like you. I'm just kidding. I'm just kidding. All right, that's the end of the strings lecture. Now, I'm going to go over something that I don't know if I'm filled with shame or not. If I had a good alternative, I would use it, but in 30-some years, I've never seen a good alternative. And using C++ in the standard template library, I'm sorry, is not a good alternative. So, what the lecture 5 here is on a library that I wrote years ago before C++ even existed, and basically gave me functionality that I could use so I could actually program with decent data structures. Okay? This is not a standard. It's not something you should bother taking with you, maybe unless you're stuck programming in C someplace. This is not a replacement for the standard template library. The STL is better than this. Okay? Easier to use, less bug prone, but this is in C. And it does and the nice thing about it from my perspective and for this class is it works in a very C-like fashion, so it helps teach you C. And think about things like memory. Okay, so what are they? We got, so I tell you how to get it. It's there on the machines. You're gonna need it for some labs, so probably not labs 1. You don't need it, but for the next lab you do. Lab 2, you are gonna need it. So this tells you how to get it. You can grab it, you can take it with you, you can do whatever you want with it. If you compile it, it might spit 8,000 warnings at you. I'm just not that invested in keeping it that up to date. Okay, but it works very nicely. So what is it? I've got an input processing, a library to help you deal with line-based input, line-based text input, which C sucks at, and frankly C++ sucks at too, in my opinion. I've got a generic data type JVal. It's horrible, but I need it. I've got doubly-linked lists. I've got red-black trees. So this takes the place of lists. It also kind of doesn't take the place of vectors, but it takes the place of pushback on a vector. C arrays you can't call pushback on. It sucks. But you can grab lists and turn them into vectors, or turn them into arrays. So lists give you that functionality. Red-black trees give you maps and sets. Okay, so that you can. So the nice thing is that now you can read in data, you can do storage and retrieval, you can do sorting, right? You can do the things that you want in the proper time with the proper data structures. So they are there. As I said, I tell you how to compile a link, take stuff. It's all good. All right, so we're going to go over the fields. We're going to go over these, and I know going over software is boring. I'm sorry. Note 3. When's class over? Is it over yet? I'm joking. Note 3. Lib. Fields. Let's do that. Okay. Do I have an include file? All right, so on my machine and on the lab machines, they're in the lab directory, so you compile. So we got a header file, ancient header file, 2001. Don't know if it's older than you or not. It's probably getting close. It is getting close. Okay. You know, I was only an associate professor then. We were in Claxton. Life was good. We were in Claxton. Actually, I shouldn't say life is bad. I actually like Mingao. It's a nice building. Okay. Now, I wrote the fields library for one reason. I was using awk to process input. And then I realized that awk was slower than crap because awk was doing memory allocation for every single thing it read. And it was slow. And so I was like, I need something that gives me awk's functionality but is not slow. And so this is what I wrote. Now the way it works is we have this thing called an input struct. It's type def. This pointer is type def to an IS. So if you're doing the IS, it's a pointer. It's okay. It's easy. Okay. And this is what's in there. Now we'll go through the ones you need to care about. When you want to create one of these, you call new input struct. You either give it a file name and it'll open that file, or you give it null and it'll open standard in. Okay? And then it'll allocate one of these, and that's it. No more memory allocation with the fields library. It does allocation exactly once. Okay? It only works on lines that are 1,000 lines long. Such is life, right? C++ is better. I get you. Okay? Then, once you call new input struct, you call getLine on the input struct. Okay? What that's going to do is it's going to read in a line and it's going to fill in these fields. Again, no memory allocation. Okay? So, what's in these fields? There's the file name. That's the file descriptor. Ignore that for now. Here's the line number. Starts at 1. Line seems like file lines can't be 0 index. That's just not what God wanted. Okay? Here's the line itself. Is there in text 1, and I use fgetS, so the line has the new line at the end of it, which sucks. If you want to tell me that sucks, I'm with you 100%. Okay, but I mean in real life we're going to use C++ anyway. We're not using this in real life, just in this class as we learn C. Okay. Text 2, ignore. NF is the number of words, so it's going to break it up into words. Okay, words are whatever, contiguous non-white space characters. Okay, so it'll tell you how many words there are, and then here's the fun one. You have direct char star pointers to every word. So if there are 2 words on the line, field 0 will point to the first word, fields 1 will point to the second one. O of 1 time, you got a pointer directly to it. Okay, ignore. Okay, but the key thing about this is, and we'll go over it. The key thing about this is, you only allocate memory when you call new input struct. And then if you call jettison input struct, it will free up that memory. Why isn't it called free input struct? Well, I mean, how often do you get to use the word jettison in your everyday life? Like never. So that's why it's there. You know, did I write this while I was a snotty Ivy Leaguer? Yeah, probably. Yeah, back then. I'm a man of the people now. And I'm upbeat. Sorry. I am upbeat, damn it. Okay. Let's go ahead and figure out where this stuff's going to be. Oh, I see. That's where I do it. So here, let me... R note 3 libfdr. Libfdr. What do you think? Make? No, nothing to be done for all. All right, that sounds good. That can't be right. How can make not work? Oh, why? I should make clean. Yeah, it's already there. It's already there. Does that mean it's right? I don't know. Is it for the right architecture? I don't know. Yeah, make clean. Good call. There we go. Hey, look at those. No warnings. Nice. Okay. All right. All right. Did we ever do the Hello World segfault? It's in the lecture notes and I didn't do it. You need this. No. There we go. This program is going to generate a segfault. Okay. Why? Well, I've got a pointer x. I'm setting it to null. So when you try to dereference null, it's a segfault. I don't get the segfault where I say x equals that. That's not the segfault. The segfault comes at star x. The star x is going to say, go find what's at memory address 0, and the hardware is going to throw a segfault. Okay. Not even a warning, but a segfault. Okay. I call this program the hello world of CS360 because this really is. This is like the very basics of what we deal with. Okay. Now, fields library. Let's write a little program. Here, we'll write junk.c. We'll keep. Okay, sure. Standard IO, standard lib. All right, and now let's include fields. Okay. In quotes because it's not part of the standard C library and the standard C include files. If this is not in this directory, when you compile, you use -I and give it a directory, and then that says, hey compiler, look in that directory for include files. And you can do that with multiple directories. Okay. So that's how I'm going to find fields.h. Now what I'll do here is I'll have my input struct, I'll say new input struct. Input struct null. If there's an error, it's going to return null. So when you're doing this, especially with files, you should check. With standard in, you're less likely to get an error, but you should probably always check your errors. But I'm not because it's class. And now I'll say while getLine is. What does getLine return? GetLine returns the number of words on the line or -1 if it's at the end of if we're at the end of input. Okay. So while getLine is not equal to -1, then do for I equals 0, I is less than is arrow and f I plus plus printf line that word that and then we'll do the line number, which is in is arrow line. We'll do the word number, which is I know I got to declare I, and then I'll do is fields I. So that's how I get at the words. I got two.
You forgot a T in input struct.
Input struct. Hold on. One at a time. Input struct, okay? And printf is printf. All right. Thank you. Good class. We're still not sure if it's going to compile, are we? Here, let's go back to here. All right, there it is in jank.c. Now, if we do gcc jank.c, I'm going to get an error, right? Because it's not going to be able to find fields.h. So if I do gcc -i libfdr include, okay, now we're good. It found fields.h. But now I got a linking error because it doesn't actually have the implementation of the fields library anywhere. So to do that, I need to include that, which is in libfdr libfdr.a. There we go. Now, you automate this in Makefiles. Okay, so you don't have to do that. I believe in my labs, when you're going to use the fields library, I give you a Makefile, which will work on our machines here, because I've got libfdr installed in a common location. Okay, so now let's go ahead and get ourselves some input. What do you think? Random names 3, one of the best programs I ever wrote. There we go. So now if I say edit out with that, okay, right, gives me each word and it gives me the line number. Okay, super convenient. All right. Now, we're going to go over this phenomenon multiple times. Okay, let's suppose we want to print out the. Okay, first off, let's change this now so we're just printing out the lines. Okay, so here are the lines. I don't need a new line. Is text 1. That actually has the line in it. Printing it twice. Why am I printing it twice?
I is less than is number of fields.
Oh, good catch. Thank you. Team Plank. There we go. Thank you. There we go. Okay. Now, let us suppose at the end of this, I want to print out the penultimate line. We all know what the word penultimate means? It means second to last. I'll give you my story. Nerdy daughter, the youngest, used the word penultimate at the dinner table. And oldest daughter, princess, told her, don't ever use that word. If you use that word, you're going to have no friends. That's what this means. Right? And I'm not sure if Princess is wrong on this one. But then Emily says the words for which I will love her forever. I'll always love her. She said, why would I not use a word which means exactly what I want it to mean? I was like, I love you. What a great thing to say. And of course Ellen's like, because you won't have any friends, you moron. So it goes. Anyway, there you go. Penultimate, use at your own risk, right? I don't need friends, so I use it. But you might need friends, so just keep it in there. So let's say we want to print out the penultimate line. So here, char star pen. Pen equals null. Let's also keep track of the last line. Last equals null. So here we go. After we read in a line, let's go ahead and set pen equal to last and last equal to is arrow text 1. Okay, so what am I doing? I'm always setting last to be the line I just read, and then I'm going to set pen to be the last thing last. So of course it's going to be null the first iteration, but after the second iteration, it's going to be printing to the penultimate line. Now this code doesn't work, I'm telling you, but pen. Okay, yeah, pen doesn't equal null. There we go. All right. All right. Oh, there we go. Sorry, we don't want the new line. Okay, it's wrong, right? It's not the penultimate line, that's the last line, is Jordan logging. Okay. Now, why is that? Well, the reason is because it's always the same pointer. Text 1 doesn't change, it gets overwritten every time I call getLine. So last is going to equal text 1 and pen is going to equal text 1. Right? I'm not copying the string, I'm just copying the pointer over and over again. So this is what I mean by it doesn't copy. And this one will get you. Just telling you, this one will get you. But we'll go through some more stuff. Now let's go ahead and clicker. All right, what do we got today? Enable 809245. Oh man, this one's going to take too much time. I have a feeling.